Now we will see an example for the topic of limit of accuracy, that means upper bound and lower bound. Here we can see an example. Given that x equal to 11, y equal to 3, correct to the nearest integers, find the upper and lower limit of x plus y, x minus y, xy and x divided by y. Before beginning any maths, we will define the upper bound and lower bound of x and y. As x equal to 11 correct to nearest integers, that means nearest 1. 1 by 2 equal to 0.5. So upper bound will be 11 plus 0.5, that means 11.5, and lower bound will be 10.5. 11 minus 0.5. And what will be the upper bound for y? 3 plus 0.5, that means 3.5, and the lower bound will be 3 minus 0.5, that means 2.5. We got the upper bound and lower bound for x and y. Now let's start the math. X plus y. Normally the value of x plus y can be 11 plus 3. This is the scenario when we did not think about the limit of accuracy. But when we are thinking about limit of accuracy and we are told that the value of x is not 11, the value of x is 11 correct to nearest integer. That means when we will calculate the upper bound of x plus y, that means the greatest value of x plus y, what will happen? We will take the largest value of x and we will take the largest value of y. Largest value of x is 11.5. So instead of 11 we will write 11.5, and instead of 3 we will write the largest value of y, 3.5. So the largest value of x plus y will be 11.5 plus 3.5, that means 15. And what will be the smallest value of x plus y, or the lower limit of x plus y? Normally the value of x is 11 and normally the value of y is 3. But when we are going to define the lowest value of x plus y, we will use the lowest value of x, that means lower bound of x. Instead of 11 we will write 10.5. In case of y, instead of 3 we will write 2.5. So the smallest value of x plus y will be 10.5 plus 2.5, that means 13. Question number 2. Now we are going to find the value of x minus y. Normally the value of x minus y is 11 minus 3. Now we are going to find the greatest value of x minus y. When we will get the greatest value? When this value is largest and this value is smallest. So what is the largest value of x? 11.5. And what is the smallest value of y? 2.5. We get the answer 11.5 minus 2.5, that means 9. This is the largest value of x minus y. And what about the smallest value of x minus y? To get the smallest value of x minus y, this value must be smallest and this value must be largest. The smallest value of x is 10.5. So we will write 10.5, and the largest value of y is 3.5. So the smallest value of x minus y will become 7. Now what about xy? Normally xy equal to 11 multiplied by 3. It would have been the value if x were given exactly 11 and y were given exactly 3. But we are said that x is not exactly 11. X is 11 correct to the nearest integer. So while calculating the largest value of xy, we must use the largest value of x and largest value of y. So largest value of x is what? Here you can see that this is 11.5 and largest value of y is 3.5. So the largest value of xy is 40.25. And what about the smallest value of xy? To have the smallest value of xy, we must use the smallest value of x and the smallest value of y. What is the smallest value of x? Here you can see that this is 10.5 and you must have memorized already that the smallest value of y is 2.5. If we multiply them, we get the value 26.25, which is significantly smaller than this. And the final question, what is the largest and smallest value of x divided by y? So if we want to get the largest value of x divided by y, the value of x must be largest and the value of y must be the smallest one. The largest value of x is 11.5 and the smallest value of y is 2.5 equals to 4.6. Now, what about the smallest value of x divided by y? If we want to have the smallest value of x divided by y, we must put the smallest value of x and the largest value of y. So, what is the smallest value of x? This is 10.5. And what is the largest value of y? This is 3.5. If we divide them, we get the answer 3. You can see that the largest and the smallest value of x divided by y has a significant change, 4.6 and 3. This type of questions frequently come in your Cambridge O-level exam and you must understand this type of maths and practice them very well to get the marks defined for these maths.